Hello and welcome to Engineer Simple. In this video, I'll talk about some Boolean algebra definitions. These are important definitions to know. So for instance, if you have logic 0 or x is the same as x. And I would recommend watching previous videos that talk about truth tables, like how to construct them. Because you can prove these definitions here using Boolean algebra. So if you have logic 1 and x is the same as x basically. So if you have x or y is the same as y or x. X and y is the same as y and x. So if you have x or y and z is the same as x and y. No. So it's the same as, so basically x or y and x or z. So if you have x and y or z is the same as, basically you take x and y or x and z. So if you have x or x naught is always logic 1, because let's assume x is 0, then x naught is 1. X or 0 or 1 is 1. As long as one of them is 1, the outcome is 1. If you start with 1, so you have 1 or 1 inverse is 0, so you have 1 or 0, which is still 1. So if you have x and x naught is always 0, because if x is 1, for instance, x bar will be 0. So 1 and 0 is always 0. Because in order for them, since we have an AND operation here, in order for them to equal 1, both must be 1. And I kind of mentioned this, 0 naught is just 1, so it's, and 1 naught is 0, so you invert it basically. So x or x is the same as x. X and x is the same as x. So if you have the complement of x, then the complement of the complement of x, basically the complement goes away. Then if you have x or x and y is equal to x. Again, you can construct the truth table and you can verify this. But if you notice here, x is the same as x and 1 or x and y. So all I added is this one here. Then if you use this operation here, so I have, basically this is what I have, I can write it in terms of this. So it's the same as x and 1 or y, right? So this here will always equal 1 regardless of what y is. Then I would have x and 1, which is equal to x. But you can use the truth table to prove that. So x and x or y is the same as x. So we can do the truth table here. So if I have x, so I have two variables, x and y, and from the previous video, the number of combination is 2 to the power of n, where n is the number of variables. I have x and y, that's 2, so I will have 4 combinations. So 0, 0, 0, 1, 1, 0, or 1, 1. That means, as you can see, x can take either 0 or 1, then you just kind of combined with y. So both are zeros, or one is 0, the other one is 1, one is 1, the other one is 0, or both are 1. So x or y, so if one of them is 1, the x or y is 1. So 0, 0, that's 0. 1, 1, 1. Now x and x or y, so I'll take x and, so basically I'm going to take this and it with this, apply an AND gate. If one of them is 0, the outcome is 0. 0, I have 0 there, I have 0 here. 1 and 1 is 1, 1 and 1 is 1. So you see, if I compare x to this expression here, they're the same. So indeed, this is true. So you see, the truth table is a powerful tool. So if I have x or x naught and y is the same as x or y. If I have x or x naught and x or y is the same as xy. And notice from the previous expression, this is just 1. So 1 and x or y is just x or y. So again, x or y or z is the same as x or y or z. Basically, you apply parentheses somewhere. So x or y or z. So basically, the order doesn't matter. So if you have x and y and z is the same as x and y and z, the same as x. So basically, the order doesn't matter. So if you have x or y, the complement of that, again, you apply the complement to each variable. So then if it's an OR, you change it to an AND. If it's an AND, you change it to an OR operator. This is called the Demorgan Law. Thank you and have a great time.